Kinematic equation for uniformly accelerated motion. Uniformly accelerated motion means we are keeping the acceleration constant. We are keeping the acceleration same. We are not changing the acceleration. Kinematic equation we have already done in class 9. There are three equations of motion. First equation of motion is V is equal to U plus AT. Second equation of motion, S is equal to UT plus half AT square, and third equation of motion, V square minus U square is equal to 2AS. So these are the three equations of motion that we had done in previous classes in class 9. Yes. अच्छा अभी हम क्या करेंगे? We will derive these three equations. You know how to derive these three equations. You have done the derivation by VT graph, है ना? We used to draw a VT graph and then we used to find slope of the VT graph and area under VT graph and we get the three different equations. ठीक है? वो तो हमें पता है ना? VT graph को use करके कैसे equations of motion निकालते हैं? तो अभी के लिए there are two ways of finding. There are two ways of writing, I would say, kinematic equation. एक तो है उसको आप simple जैसे you have done in class 9 in the same way you can do. Second is we can write these equations in vector form. We can use calculus and derive the equations. Calculus is the same that differentiation integration that you have done already. Okay, using differentiation and integration, we can derive this. We can derive these equations of motion. एक तो हो गया वो calculus method and the previous method, the same method that you have done in class 9, वो हम same method से भी करेंगे और calculus से भी करेंगे. In your exams, they ask you to derive the equations by calculus method because this is new for you. This is something which you are doing the first time. For the first time, right? You have never done before. So they ask you to derive the calculus, derive the equations of motion using calculus method only. Okay, but हमें दोनों methods आने चाहिए. हमें पता होना चाहिए कैसे कैसे, right? So let's start from the equations. So kinematic equation for uniformly accelerated motion. So for this we draw a graph. So what does this graph indicate? What do you just looking at this graph? What do you observe? At time t equals to 0, object is at B and it is moving with some initial velocity V naught. So we are taking V naught as the initial velocity of the object. And after some time, its velocity has been changed to V in time t. And we know that we can see the graph is straight. It is inclined to time axis. So acceleration is uniform here. It is moving with constant acceleration. Every time there is equal change in velocity in equal time. हर बार जो है velocity में change equal हो रहा है equal time में. It is moving with constant acceleration. It is moving with uniform acceleration. Okay. So what is the initial velocity? V naught. Final velocity V. Time कितना लगा change के लिए? It's t. Okay. So we can find two different things from a graph. We can find slope of the graph. We can find area under curve. If we find slope of the graph, what quantity do we get? We get acceleration by finding slope of the graph. And if we find area under curve, then we get displacement. So we can find two different quantities using this graph. One is acceleration, another is displacement. Yes? Okay. So let's consider the terms. Displacement is x, time taken t. We have already discussed. Initial velocity is v naught, final velocity as v. Please write this in your notebook. Draw the graph and write these terms. Acceleration is a, final velocity is v, initial velocity is v naught, time taken is t, and displacement is x. Okay. So the three kinematic equations for uniformly accelerated velocity. The first equation is v is equal to v naught plus at because we are taking initial velocity as v naught here. V naught represents t equals to 0 or initial. Okay. Second equation of motion is position time relation. And third equation of motion is position display and velocity relation. Position velocity relation. Yes. So let's derive v is equal to v naught plus at. How do we derive v is equal to v naught plus at? We take the slope of the graph. Okay, we have the same graph. We can find slope of this graph. How do we find slope? y2 minus y1 upon x2 minus x1, right? कैसे find करोगे slope? A is dv by dt, change in velocity upon time. So we can write A as v minus v naught upon t. From here we get at is equal to v minus v naught or v is equal to v naught plus at. Slope कैसे find करते हैं? y2 minus y1 upon x2 minus x1. Yes. So we can choose the coordinates here. Let this coordinate be this abscissa we write first. For time it is 0 and velocity is v naught. And here write the coordinates. Time is t and velocity is v. And slope of vt graph gives the acceleration. So acceleration is slope of vt graph. Yes. C का नो वेलोसिटी यहां तक v नॉट है बेटा और ओरिजिन से नीचे तक v है. ठीक है. हाँ, this is v naught, this is v and this is v naught. ठीक है, आ गया समझ? तो acceleration is v minus v naught y2 minus y1 upon x2 minus x1. x2 minus x1 is t minus 0. Move this to the other side. We'll get v minus v naught as at. This implies v is equal to v naught plus 8. So this is the first equation of motion. Derive second equation of motion. So second equation of motion is x is equal to v naught t plus half at square. Because here we have displacement, velocity, and time. Yeah, these quantities we have here in this equation. So for this we need to find displacement. So we will find area under curve in the same VT graph that we have. Okay, so area under curve, we can see that this shaded portion represents area under curve. How do we find area under curve? We draw the curve and find the area with time axis. So here we have a triangle and a rectangle. Okay, so we'll find the area of these two things, these two shapes separately. Okay, so OA is T because OA is T and therefore BD is also T. Opposite sides of rectangle we can say, or they're equal, na? And OB is V naught. Vertically, it is V naught. CD is equal to BF. And how do we write BF? BF is OF minus OB. What is OF? OF is V and OB is V naught. So it's V minus V naught. Okay, this is how we write first equation or the expression for acceleration. It's V minus V naught upon T. So we can write V minus V naught as AT. Because we'll use this thing. So कहीं पे भी जहाँ पे भी derivation में आएगा ना V minus V naught, so we will write AT for V minus. इसको अपना ध्यान रखना है हमने कि V minus V naught जो है वो AT है. Okay. So displacement, how do we find displacement? We'll take the area under curve. It's OACB. We'll find the area of this shape. And this is a triangle plus rectangle. So we'll find the area separately of triangle and rectangle. What is the area of triangle? How do we write area of triangle? Length into breadth. Length is OA and breadth is AD. Or OB we can write. And area of triangle is half into base into height. Base is BD, or we can write OA or BD. They are same. And CD. Okay, now we'll put the values. ये कैसे आया? What is OA? OA is T. OB is V naught. OA is T. CD is AC minus AD. Or we can write OF minus OB. It's B minus V naught. Okay. For V minus V naught, we can write 80. So we'll get this equation. This is the second equation of motion. किसको नहीं आया? नहीं आया तो पूछ लो मेरा। आ गया ना? पता है ना ये कैसे कैसे लेना है? ये V है आपका, पूरा V है, एंड दिस इज V नॉट, दिस इज V minus V. Okay, this is T, so this is also T. This is V minus V naught. This is V naught. Okay. Anything you want to ask? So let's derive third equation of motion. It's V square is equal to V naught square plus 2Ax. See here in this equation also we'll find area under curve, but this time we will, when we find area under curve, then we will not divide this into triangle or a rectangle. We can consider this as one figure, and we can see that one pair of sides are parallel. Yes, we have OB and AC parallel to each other. So it is a trapezium. And how do we find area of a trapezium? Yes, half into sum of the parallel sides multiplied by distance between the parallel sides. This is how we find trapezium area of trapezium. Okay, so X is area under BT graph. यहाँ पे भी एरिया फाइंड करना है, सेकेंड इक्वेशन में भी एरिया फाइंड और थर्ड में भी एरिया फाइंड करना है. The only difference is there we divide the area into two parts, triangle and rectangle, and here we're taking this as one trapezium. Okay, so this is area of trapezium AOBCDA. Okay, and area of trapezium is half into, कैसे आया ये? Sum of parallel sides. OB is B naught, AC is B, and distance between the parallel sides is T. And for T, we will write V minus V naught by A, because we'll use the relation of acceleration here. So on solving, you'll get this. Okay? Because this is V naught and this is V, right? So if we are finding area of trapezium, we need this parallel side, and this parallel side is needed. So it is V. AC is equal to OF, है ना? Both are equal to V, and this distance between the parallel sides is T. You can take this as T or this as T, it's your choice. Okay? So we are using this half into OB plus AC into OE. This is what we have done. Okay, and because acceleration is V minus V naught by T, so we can write T as V minus V naught by A. Okay, there is another method of deriving this. See how can we derive? We know the two equations, right? So from first equation, it's V is equal to V naught plus AT. Then from there, we can get the value of T. We can write T as V minus V naught by A. Okay. And from second equation, we have X is equal to V naught T plus half AT square. So we'll simply substitute this value of T in equation 2. From equation 1, we will put this value in equation 2. So for T, we'll write V minus V naught by A everywhere, wherever we have T in the second equation. Okay, so we'll get this. Now, we will solve this. Expand this. Okay, we'll use the formula, we'll use the that thing, that A minus B whole square algebraic identities that you have done in lower classes. It's A square plus B square minus 2AB. We'll use that thing here, expand this and solve this. So you'll get these expressions. We'll cancel the expressions, positive, negative to cancel हो रहे हैं, उसको cancel कर देंगे. We'll further solve it, simplify it, and we get the final relation as X is equal to V square minus V naught square by 2A. We get this equation. Okay, this is another way of deriving the third equation of motion. Okay. From the first two equations, हमने क्या किया? फर्स्ट इक्वेशन से t की वैल्यू निकाला, उसको सेकेंड इक्वेशन में पुट किया, एक्सपैंड किया, जो कटता है काट दिया, सॉल्व किया, सिंप्लीफाई किया, एंड वी हैव गॉट दिस. Is that difficult? Now we have questions based on this. Kinematic equations are applied for a uniformly dashed motion. Circular, distorted, decelerated, and accelerated. Kinematic equations are applied for a uniformly motion, dash motion. Yes, it's accelerated motion. Next question. So the average velocity of a body moving with uniform acceleration, traveling a displacement of 3.06 meter is 0.34 meter per second. If the change in velocity is 0.18 meter per second during this time, find the uniform acceleration. So average velocity is given. Average velocity is equal to 0.34 meter per second. Displacement is given. Displacement is equal to 3.06 meter. Change in velocity is given. Change in velocity is 0.18 meter per second. We have to find acceleration. कैसे करोगे? Mudit? Velocity and displacement is given, so we can easily find time. And once we get time, change in velocity is also given, so we can find acceleration. Okay, how will you find time? Time, displacement, and velocity में क्या relation है? Velocity is displacement upon time. So this implies time is equal to displacement upon velocity. Displacement is given, it is 3.06. 3.06, and velocity is given, it is 0.34. You can solve this to find the value of time. Yeah. Yes, it is 9 seconds. Okay, and acceleration is change in velocity upon time. Change in velocity is given, it's 0.18. Time is given, it's 9. So we can find acceleration, it's 0.02 meter per second square. Being a board of speed limit, you break a car from speed of 108 km per hour to a speed of 72 km per hour constant acceleration, and car travels 100 meter during this interval. Okay, so what is the acceleration? How much time is required for the given decrease in speed? So initial speed is given. It is 108 km per hour. We can convert this into meter per second. 5 by 18 से multiply कर देंगे. You get it in meter per second. What will you get? This is the initial velocity. And final velocity is? Final velocity, let's denote final velocity by V. It is 72 kilometers per hour. 72 kilometers per hour is equal to, in meter per second, it is 5 by 18 into 72 meter per second. Okay? So we can convert this. Displacement is given, it is x. X is 100 meter. कुछ और दिया हुआ है जो मिस कर रहे हैं? नहीं, है ना? We have to find acceleration and how much time is required for the given decrease in speed. These two quantities we have to find out. Easy. We have to apply two different equations of motion here. So when we convert this in meter per second, we get 30. and here it's 20. Okay, so first we'll find acceleration. How do we find acceleration? We'll use third equation of motion. Yes, so v square minus u square is equal to 2ax, which implies x is equal to v square minus u square upon 2a. Now put the values here. V square is 20 square minus u square is 30 square divided by 2 into. No. We'll write a, na? We have to find a, not x. X is given. So we'll write a here and x here. So it's 2 into 100. Okay. What will you get? It's 400 minus 900 divided by 200. This is, what are you getting? Minus 500 by 200. Minus 5 by 2 or minus 2.5 meter per second square. This car is retarding. Its speed is decreasing. How much time is required for the decrease? For this, we can use the relation v is equal to u plus at. So from here, we'll write t as v minus u by a. Now we'll put the values here. V is 20, u is 30, a is minus 5 by 2. Let's write minus 5 by 2. Okay, so minus 5 here and 2 here. Okay. So we'll get minus 10 into 2 by minus 5. Minus cancel. 5 ones are 5. 5 twos are 10. Answer is 4 second. Is this what you're getting? Yes. Are you getting the same answer? You all are getting the same answer? Yes. Yes. Distance traveled by the object in nth second. See, if we consider a situation that we have an object, okay, and it is moving with initial velocity u, okay, and it covers some distance s in time t and reaches here, and now it is moving with velocity v. So there is a change in velocity. This object is accelerating. है ना? Assume the situation where we have uniform acceleration. See, whenever we write kinematic equations, whenever we write equations of motion, then we assume object to be moving with uniform acceleration. Uniform acceleration means there is equal change in velocity in equal intervals of time. Acceleration is constant. So, distance covered by the object in t seconds. Let this time is in seconds. In t seconds is, using second equation of motion, we can write this as ut plus half a t square. Okay. This is the equation of motion. Second equation of motion, yes. Now consider a situation. Suppose we have an object and this object is moving in a straight line and it is covering 1 meter in 1 second. Let's assume that it is covering 1 meter in 1 second. Okay. So 1 meter in 1 second. Okay. Next, 1 meter in 1 second. And you can assume anything. मतलब कुछ भी ले सकते हैं ऐसे, but it is moving. This object is moving in a straight line. Okay. This is first second. It covers some distance in second. 3 seconds. This much distance has been covered by the object in 4 seconds, 5 seconds, 6 seconds, 7 seconds. Yes. Eight seconds, 9 seconds, and 10 seconds. Fine. So if I say that find the distance traveled by the object in 10 seconds, then what will you write? In 10 seconds, object has covered a distance of 10 meter. Okay, so this is 10 meter in 10 seconds. 10 meter in 10 seconds. Okay. Now tell me distance covered by the object in 9 seconds. Okay. In 9 seconds, it covers a distance of 9 meter in 9 seconds. Okay. So this is the distance covered by the object in 10 seconds. It is 10 meter. We can write as 10, subscript 10 for this. And this is the distance covered by the object in 9 seconds. It is 9 meter. Again, subscript 9 for 9 seconds. Subscript 10 for 10 seconds. Okay. If I ask you to find the distance covered by the object in 10th second, 10th second, how will you find? Yes, it's 1 meter. Very good. 1 meter ही आएगा ना. This is the 10th second. 10 second मतलब 9 seconds से start होके 10 seconds तक. This is your 10th second. So what is the distance covered? It is 1 meter. How will you find the distance? It's S10 minus S9. Distance covered in 10 seconds is 10 meter and distance covered in 9 seconds is 9 meters. So we can simply subtract them and we'll get this. यही concept हमने use करना है. Using this concept, we will find the relation. Okay, we will find the equation of distance traveled by the object in nth second. Okay, चलो 10 second का is 10 minus 9. And if I ask you to find distance traveled by the object in nth second, then 10th के लिए we write 10 first and then 9. And nth के लिए we'll write n first and Sn minus 1. 1 less than 10. 1 less than n here. Here we have 9. 9 is 1 less than 10. And n minus 1 is 1 less than n. Any doubt? Good. Okay. So, distance covered by the object in t seconds. How we write? How do we write distance covered by the object in t seconds? St is equal to t plus half a t square. Similarly, we can write distance covered by the object in n seconds. Yes. For t, we will write n now. So it is un plus half a n square. Let this be 1. Similarly, we can write distance covered by the object in n minus 1 seconds. This is equal to u. Now in place of t, we will write n minus 1. है ना? U n minus 1 plus half a n minus 1 whole square. Let this be 2. Therefore, distance covered by the object in nth second. Distance covered by the object in nth second is equal to Sn dh. See, this is Sn and this is Sn minus 1. Yes? So we can write distance covered by the object in nth second as distance covered by the object in n seconds minus distance covered by the object in n minus 1 seconds. Okay? Any doubt? This implies distance covered by the object in nth second is equal to, for Sn we will write un plus half a n square. For Sn minus 1 we will write u n minus 1 plus half a n minus 1 square. Okay, now expand this. So un plus half a n square, and this is in one bracket, and second bracket we will write this u n minus u, yes, plus half a. See, n minus 1 whole square, no? We can apply a minus b whole square here. So it is a square plus b square minus 2a. un plus half a n square minus un minus u plus half a n square plus half a minus a n. Yes, 2 से 2 cancel हो जाएगा and we have this a n. Now we will write un plus half a n square, open the bracket, plus minus 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 plus minus minus half a n square plus minus minus a by 2 minus minus plus a n. Any doubt? No? Hmm? un cancel हो जाएगा, half a n square cancel हो जाएगा, and we are left with the distance traveled by the object in nth second is equal to u plus a n minus a by, ठीक है, or we can write u plus, see, what if I take a by 2 outside? Then in the bracket we'll have 2n minus 1. This is the relation. I'm going to rub this. This is the distance traveled by the object in nth second. It is equal to u plus a by 2, 2n minus 1. And close this in box. Final expression. Okay. Body covers 10 meter in fourth second है बेटा, and 15 meter in sixth second of its uniform accelerated motion. How far will it travel in the next 3 seconds? So we can write s fourth equals 10 meter, and it covers 15 meter in sixth second. Sixth second में it is covering 15 meter of its uniformly accelerated motion. How far will it travel in the next 3 seconds? देखो, 4th second, 6th second. Next 3 seconds में कितना distance cover करे? Next 3 seconds means 6 second to 9 second. Okay. So we have to find S9 minus S6. Yes. So for this, because displacement is ut plus half at square for n seconds, है ना? For t seconds here we can write. Okay. And distance traveled in nth second, how do we write? Let's write in terms of t, n only, because we are dealing with this nth second now. So let's write in terms of n only. Distance traveled in n seconds is Sn. It is equal to u plus half a n square. And distance traveled in nth second is u plus, what is the formula? A by 2, 2n minus 1. Okay. So in fourth second, when n is equal to 4, in fourth second, we can write it is u plus a by 2, 2 into 4 minus 1, and it is equal to u plus a by 2. And here we have 4 to the 8 minus 1, 7. 7a by 2 is equal to 10. This is given to you. Let this be 1. Similarly, we can write for sixth second. For sixth second, we have u plus a by 2, 2 into 6 minus 1. So u plus 6 to the 12. 12 minus 1 is 11. 11 a by 2 is equal to 15. Let this be 2. Okay, now subtract these two. 2 minus 1. 2 minus 1 gives u plus a by 2, 11a by 2. First you will write this, and then you will write u plus 7a by 2. You've done, Avni? Is equal to 15 minus 10. You see you cancel ho jayega. 11a minus 7a is 4a. So 4a by 2 is equal to 15 minus 10 is 5. So this implies a is equal to 2 into 5 by 4. 2 ones are 2. 2 twos are 4. Acceleration is 2.5 meter per second square. Because this time is in second and distance is in meter, so we'll write acceleration in meter per second. Similarly, as we have found out this acceleration, the same way we can find the value of u. Okay, so u is u plus, put this value of a in 1, u plus 7. A is 5 by 2, 7 by 2 into, we can write 5 by 2, for a is equal to 10. So you'll get the value of u from here. It is 10 minus 35 by 4. 40 minus 35 is 5 by 4 meter per second. Okay? Or we can write 4 ones are 4.25 meter per second. Okay, so what is the value of A? It's 2.5 meter per second square, and value of U 1.25 meter per second. Yes. Okay, next 3 seconds. First we'll write distance covered by the object in 9 seconds minus distance covered by the object in 6 seconds. Okay, so we'll put value of n as 9 first and then 6. We can write u, 9u plus half a n square. 9 square is 81 minus 6u plus half a 6 square is 36. 9u minus 6u is 3u, and here we have 81a by 2, and here we have minus 36a by 2. So we'll get 3u plus 11 minus 6 is 5. 7 minus 3 is 4. 45a by 2. Now put the value of u and a. So distance traveled by the object in next 3 seconds. 6 to 9 is equal to 3. Put the value of u. In fraction, we can write 5 by 4. 1.25 can be written as 5 by 4 plus 45. And this 2.5 is 5 by 2 now in fraction. We can write in fraction form, it's 5 by 2. So we'll get 15 by 4. 45 fives are 225 नहीं आ रहा by 4 फिर 15 ऐड करो 25 plus 15 is 40 240 by 4 6 240 आ रहा है 60 आ रहा था yes 240 by 4 is 60 meter. The distance traveled by the object in next 3 seconds from 9 second from 6 second to 9 second is 60 meter. Next, motion under gravity for a freely falling body. See, if we have vertical motion and body is dropped vertically downward, then it falls freely due to gravitational force of Earth. So an object is released under the influence of gravity. It is said to be free fall, where the initial velocity is 0 and acceleration is g, and distance is height from which it was thrown. Okay, so when we release the object from a certain height, then its initial velocity is 0, and velocity of the object increases as it moves towards the Earth's surface, and it strikes the ground with maximum velocity. So here in this case, acceleration is acceleration due to gravity, and the value of acceleration due to gravity is 9.8 meter per second square. पता है ना? Direction of motion and direction of acceleration due to gravity different है या same है? Object is moving in downward direction. Acceleration due to gravity is also acting in the same direction. दोनों same direction में है. G is positive. Okay. यहाँ पे इनिशियली जब भी आप किसी चीज को ऊपर से थ्रो करोगे ना, देन यू पुट इनिशियल वेलोसिटी एज 0. बस ये ध्यान रखना है. एंड a is plus g. And for vertical motion we write s as h. Okay. So how do we write equation for this kind of motion? We can write v is equal to v naught plus gt. This is the first equation of motion. Second equation of motion can be written as h is equal to v naught t plus half gt square. Third equation of motion is v square plus v naught square is equal to 2gh. And the fourth equation that we have just found out is distance traveled by the object in nth second is written as v naught plus g by 2 2n minus 1. So a is replaced by g. ठीक है? Written. If the body is projected in vertically upward direction, if the body is projected in vertically upward direction, then object is moving against the gravitational force of Earth. Yes, G will be negative. Body is thrown vertically up. So when an object is thrown vertically up, then it is thrown with some velocity. We apply force on the object, है ना? And it goes in upward direction. कुछ ना कुछ force apply करोगे, किसी ना किसी velocity से ही जाएगा ना वो ऊपर. So initial velocity is not 0. It has some value, but when the object reaches at the maximum height, their velocity is 0. Okay, so final velocity we can say is 0. When the object reaches at maximum height, their velocity is 0. V is 0. V naught is not 0. A is equal to minus G. We take minus G because object is moving against the gravitational force of Earth, and therefore we put a negative sign. And how do we write equation? Because A is minus G, we will write B is equal to V naught minus GT. H is equal to V naught T minus half GT square. V square is equal to V naught square minus 2GH. Okay, so this is how we write equations of motion. So body projected vertically up, na? So we write acceleration as minus G, and these are the equations that we have discussed. So here angle between velocity vector and acceleration vector is 180 degree because object is moving in upward direction with some velocity and acceleration is acting in downward direction. The angle between velocity and acceleration is 180 degree until the body reaches the highest point. Okay. So at maximum height, B is 0 and A is equal to G. How do we get this? कैसे आया? बताओ बताओ. Third equation. Very good. We have applied third equation of motion here. We get this. I'll explain. Object is with moving thrown up with some velocity v naught, and when it reaches the highest point, then its velocity becomes 0. V is 0, and at maximum height, for maximum height, using third equation of motion, we have this v square minus v naught square is equal to 2g h max. Okay, so this v square is 0. We can write h max as v naught square by 2g. Point then v is 0, na? Yes. So time taken by the object to reach at the highest point is t we are taking. Why are we taking this v0? हम बीच में कहीं पे नहीं डिस्कस कर रहे हैं. बीच में तो इसकी वेलोसिटी कुछ है. It is decreasing with time. And at the highest point it becomes 0. है ना? So highest point पे, this is the time taken by the object to reach at the highest point. So this is the time taken by the object to reach at the highest point, and it is equal to v naught by g. ठीक है. अब जितना टाइम ऊपर लगेगा उतना ही टाइम में वो नीचे आएगा वापस. टोटल टाइम कितना हो गया? टोटल टाइम ऑफ फ्लाइट v naught by g plus v naught by g, it's 2 v naught by g. So this time depends on the velocity with which the object was thrown up, and height also depends upon the velocity with which the object was thrown up, square of velocity, initial velocity. Yes. Now we have a question. A ball is thrown vertically upward with a velocity of 20 meters per second from the top of a multi-story building. The height of the point from where the ball is thrown is 25 meters from the ground. How high the ball will rise? How long will it be before the ball hits the ground? Take G is equal to 10 meters per second square. This is square. So a body is thrown vertically upward with a velocity of 20 meters per second. So U is 20 meters per second. And ball is thrown from here. How high the ball will rise? This is the question. Yes. Kinematic equations of motion using calculus method. So how many equations are there? 4. कौन सी? V is equal to U plus 80. S is equal to UT plus half AT square. V square minus U square 2AS. And for nth second, we write U plus A by 2, 2n minus 1. Okay. Now we are going to derive the first 3 equations of motion, the 3 equations of motion using calculus method. So first equation of motion is V is equal to U plus 80. How do we derive this equation? By taking the slope. But here we will use differentiation. ठीक है. वहां पे हमने slope लिया था. We had used VT graph, and using VT graph we had found out the acceleration, and then from acceleration we have got the equation. First equation of motion. By taking area under curve, we get the displacement, and we have derived second and third equation of motion. So in this section, we will use calculus method. We'll use differentiation integration tools and we'll derive the equations of motion. Okay. So let's consider an object moving in a straight line with uniform acceleration. Uniform acceleration means object is moving with constant acceleration. Acceleration is not changing, but there is change in velocity. There is equal change in velocity in equal intervals of time. And consider the object's velocity as u at t equals to 0. So the time at which we have started observing the object, at that time velocity of the object is u. It was moving with some velocity u. And after time t, it attains velocity v. So there is a change in velocity. There is acceleration. Okay. So first relation is velocity time relation. Velocity time relation is v is equal to u plus at. And how do we write acceleration? It is change in velocity upon time. Okay. And change in velocity is dv, and time interval is dt. Okay, dv is the change in velocity in time, dt. So we can write dv as a dt, है ना? dv as a dt. Now we will integrate this. How is the velocity changing? Velocity is changing from u to v. Initial velocity is u and final velocity is v, and time is from 0 to t. Okay, so now we will integrate this and we'll put the limits like this. At t equals to 0 we have u, at t equals to t we have v. Accordingly we'll put the limits. By integrating both sides we get this. Okay, on integrating dv we get dv v. So from here we get v is equal to u plus at. This is the first equation of motion. In vector form we write the equation like this. This is the vector form of this equation. See. Okay. Acceleration is dv by dt. इसमें तो कोई डाउट नहीं है ना हमें, है ना? And dv is a dt. यहाँ पे भी कोई डाउट नहीं है, right? At time t equals to 0, velocity is u. At t, velocity is v. So we'll integrate this. On integrating, we'll put the limits. When we have t is equal to 0, velocity is u. When we have time t, its velocity is v. Now we will use the relation x and dx. X and dx. X and dx is xn plus 1 upon n plus 1. So we have no limits here. So we write the constant of integration with this. And if we are given the limits, then there is no need to write constant of integration. Okay. So here we have dv. So we can write this as, see, this dv can be written as v naught dv. Integrate from u to v. And a, and this dt can be written as t raised to the power 0. dt again integrated from 0 to t. Okay. Now what is the value of n? N is 0. N is 0 na? Because x raised to the power n hai hamare paas. So v naught, v raised to the power 0. N is 0. Okay, so it's v0 plus 1 upon 0 plus 1 u to v. So jor se 0 plus 1 upon 0 plus 1 integrated from 0 to t. Okay, so now you have this v only because v upon 1 is v. So it's v, and write the limits. A, write the limits. अब क्या करते हैं? First we put the upper limit and then we put the lower limit in u. Lower limit is u, so we'll write v minus u. A, first we write upper limit, t के place पे t लिखेंगे, minus अब t के place पे 0 लिखेंगे, ठीक है? This is how we integrate. So this relation is v is equal to u plus 8. Next is the second equation of motion. Second equation of motion tells us about the distance time relation. It is s is equal to ut plus half at square, right? So let's consider a situation if the object is moving in a straight line with uniform acceleration a at any instant t. The distance traveled by the object in time interval dt is ds. See, in small time interval, small distance will be covered by the object. In small time interval dt, small distance ds will be covered by the object. Yes. So we can find instantaneous velocity at that instant. At that point of time, what is the velocity, with what velocity it is moving? Okay, we can find that. So how do we write v in terms of displacement and time? V is equal to ds by dt. So we can write ds as v dt. And what is v? It is u plus at. We can expand this further. It is u dt plus at dt. Without. Now we'll integrate this again, both sides. Because initially we are considering object at, the reference point only. It is moving away from the reference point and covering some distance s. So at time t is equal to 0, the displacement covered, distance covered by the object is 0. Because object is at the reference point from where, the point where from where we are measuring the distance. And once it starts moving, then it is moving away from the reference point or it is covering some distance. Distance is increasing with time. Okay, तो दूर दूर जा रहा है ना ये, तो s का एक finite value will get. After time t, Assume that the object has covered a distance small s in time t. Small s distance has been covered by the object. So at t is equal to 0, s is 0. At t is equal to t, we have a finite value of s. तो देखो यहाँ पे अपने इंटीग्रेशन में ये ध्यान रखना है कि जब आप t को 0 रख रहे हो, लुक एट द कर्सर मूवमेंट, तो आप s को 0 रख रहे हो, उसके कॉरेस्पॉन्डिंग लोगे आप, और एट टाइम t इज इक्वल टू t, डिस्टेंस इज s. ठीक है. Now we will integrate this. On integrating, we get this relation. S is equal to ut plus half at square. Okay. See here also. इसमें हम क्या assume कर रहे हैं कि initially जो object है it is at origin or at the reference point we are choosing and s is 0 at t equals to 0. ठीक है. उसके बाद object has covered some distance s at time t. After time t, object is 0. Okay. 0 to s जब integrate करोगे तो you'll get s minus 0 ना. You will get s minus 0. This is s. Now put the limits 0 to s. Again, we have used the same formula x and dx upon n plus 1. X and dx wala. It's xn plus 1 upon n plus 1. Okay. So we have s0 na. So s0 ds. S0 is s0 plus 1 upon 0 plus 1. Now put the limits 0 to s. Okay. जैसे अभी लास्ट किया था वैसे ही करना है. अब यहाँ पे भी dt है, तो dt क्या हो जाएगा? t हो जाएगा. For dt we can write t, and for this t dt, see यहाँ पे t की पावर 1 है, तो t की पावर 1 है, and we have this dt 0 to t. Again use the same relation xn plus 1, t raised to power 1 plus 1 upon 1 plus 1, and write the limits, lower limit and upper limit. So it's t square upon 2 है ना. t square upon 2 हो गया. t square upon 2 and write the limits now 0 to t. Okay, on solving this, you will get this equation. Next, we have velocity displacement relation. So velocity displacement relation is the third equation of motion. Third equation of motion is v square minus u square is equal to 2as. Okay. So for this, we know acceleration is dv by dt. So we can write dv by dt as dv by ds multiplied by ds by dt. We have simply multiplied and divided by ds only. ds से multiply भी कर दिया और ds से divide भी कर दिया, तो we get this dv by ds into ds by dt. Now what is this ds by dt? This ds by dt is instantaneous velocity. ds by dt is instantaneous velocity. So we can write for ds by dt, we can write v. So it's v into dv by ds. Any doubt in this? क्या किया हमने? We had acceleration. Acceleration is dv by dt. We have simply multiplied it and divided by ds, and we have written this ds by dt as v. In place of ds by dt, we can write v. So it's v into dv by ds. Okay. Now we'll move this ds to the other side. We'll get v dv is equal to ads. V dv is equal to ads. Okay. आ गया v dv ads. अब क्या है? At time t is equal to 0, initial velocity of the object is u and distance covered by the object is s. So at t is equal to 0, s is 0 and velocity is u. At t, after time t, velocity becomes v and displacement is s. Okay. So integrating both sides within the conditions, we get this. See, आपने वही corresponding आ गया. At time t is equal to 0, velocity is u and displacement is 0. So if displacement is 0, velocity is u. And after covering some distance, displacement becomes s and velocity is v. Again integrate this. We will get this on integrating. This is the final equation. In vector form, we can write this equation as this. at t is equal to 0. Object is moving with velocity u and distance covered by the object is 0. After time t, velocity of the object becomes v and displacement is s. Okay. So if you are integrating, then you have to put the limits of displacement here because अब displacement को integrate करो तो displacement की कुछ करके इसको बाहर निकालो, कुछ कर सकते हो या वहां वाली लाइट ऑन कर दो, दोनों लाइट्स, ये यहाँ दोनों स्विचेस, दोनों स्विच ऑन, देखो कुछ होता है तो ये वाली लाइट कम कर दो यहाँ से। ठीक है, तो डीएस की लिमिट्स पुट करोगे, है ना, तो डीएस की लिमिट्स पुट करोगे, डीएस की लिमिट्स एट टी इक्वल्स टू 0, एस इज 0 एंड वी इज यू, है ना, एस इज 0 एंड वी इज यू, एंड आफ्टर व्हेन द आफ्टर टाइम टी ऑब्जेक्ट हैज कवर्ड दिस मच डिस्टेंस एस एंड वेलोसिटी बिकम्स वी, यहाँ पे कोई डाउट नहीं है। अब ds को जब आप इंटीग्रेट करोगे, और इंटीग्रेटिंग ds वी गेट s, नाउ पुट द लिमिट 0 to s, s a को हम as it is लिख रहे हैं, see we are not including a here because we are assuming a as constant, we are considering this motion as uniformly accelerated motion. In uniformly accelerated motion, acceleration is constant, so whenever we are integrating, we are डिफरेंशिएशन किसका ले रहे हैं हम, डिस्प्लेसमेंट का ले रहे हैं, वेलोसिटी का ले रहे हैं, टाइम का ले रहे हैं, बिकॉज टाइम चेंज हो रहा है, वेलोसिटी चेंज हो रही है, डिस्प्लेसमेंट चेंज हो रहा है, but acceleration is not changing. That's why we're not writing dA here. A is not a variable, A is a constant. यूनिफॉर्म एक्सेलरेशन है, नॉन यूनिफॉर्म एक्सेलरेशन नहीं है, ये ध्यान रखना है हमने, ये यूनिफॉर्म एक्सेलरेशन है। ठीक है, अब VdV, VdV is v square by 2 because again we have used this equation relation na, x and dx wala. Okay, so it's v raised to power 1, so 1 plus 1 upon 1 plus 1 is 2, v square by 2. Now put the limits. First we will put the upper limit, we get v square by 2, है ना, तो as is equal to v square by 2, and now we'll put the lower limit, and lower limit is u, so in place of v we will write u this time, so it's u square by 2. Okay, so 2as is equal to v square minus u square, and in vector form we have written the equation like this. See, all these variables, they are vectors. Velocity is a vector quantity, acceleration is a vector quantity, displacement is a vector quantity, and when we take the dot product of two vectors, what do we get? 3 hours की क्लास लेने के बाद मुझे याद नहीं आ रहा कि डॉट प्रोडक्ट में क्या था। वेक्टर a डॉट वेक्टर a, व्हेन यू टेक द डॉट प्रोडक्ट ऑफ नो 1 तब लेते हैं जब हम यूनिट वेक्टर्स को डॉट प्रोडक्ट लेते हैं। अगर आप वेक्टर्स का, दो वेक्टर्स का डॉट प्रोडक्ट लेते हो, देन यू गेट स्क्वायर ऑफ द मैग्नीट्यूड ऑफ दैट वेक्टर, इट्स a स्क्वायर। देखो ना, व्हाट इज द एंगल बिटवीन दीज टू? Angle is 0 degree ना, both the vectors are same, they are pointing in the same direction. Vector A अगर इस डायरेक्शन में पॉइंट कर रहा है, दूसरा वेक्टर A भी सेम डायरेक्शन में उसी लाइन में पॉइंट करेगा ना, then what is the angle? Angle is 0 degree. And how do we write dot product? Vector A dot vector B is AB cos theta. This is how we write. इतना तो याद है, ये भी भूल गए हम। Vector A dot vector B is AB cos theta. यहाँ पे क्या है? First we write the magnitude of this vector, and then magnitude of second vector, and the angle between these two vectors is 0 degrees, cos 0 degree is 1. अब इसका magnitude we can simply write a cos 0 degree is 1, so it's a square. ठीक है, so as we write this vector a dot vector a as a square, in the same way we can write a square as vector a dot vector a, वापस उसको भी तो लिख सकते हैं वैसे, तो वही यूज करके we are writing for v u and a as v square है, so we can write this as vector v dot vector v, because जब इसको आप ओपन करोगे ना, तो you'll write magnitude of first vector, magnitude of second vector, and cos 0 degree. Cos 0 degree is 1, so it is v square, and here u into cos 0 degree again 1, u square, to a dot s, vector a dot vector s. Okay, again dot product. So vector form of this equation can be written as this. Acceleration of a particle is given by, acceleration of the particle is given by A is equal to 2t square meter per second square. If it is at rest and at the origin at time t equals to 0. So at t is equal to 0, object is at rest, means its velocity is 0. Initial velocity of the object is 0. And it is at the origin. Origin means x is 0. X for displacement, if you're writing displacement as s, you can write s. It's your choice. You can use, it is just a notation. You can write s or you can write x. It's your choice. Okay, s is also 0 at t equals to 0. Initial velocity is 0. It is at rest. We have to find its position, velocity, and acceleration at time t equals to 1 second. So after 1 second, we have to find the position of the object, velocity with which it is moving, and acceleration at t is equal to 1. Okay, so for acceleration, it's easy. It is given 2t square meter per second square, right? So at t is equal to 1, we can write for acceleration, it's 2 into 1 square. Okay, so acceleration is 2 meter per second square. Easy. Now for velocity, we know the relation. A is equal to dv by dt. So this implies we can write dv as a dt. Okay. Now we'll integrate this. On integrating, see, when we integrate, we put the limits, na? So for dv, what limits should I write, and for dt? Yes. At t is equal to 0, velocity is 0. After time t, velocity is v. Initially, velocity is 0. Object is at rest. है ना? It is, if it is at rest and at the origin initially. So now I'll integrate this. So it's v. Now write the limits. Lower limit, upper limit. A. On integration, we get t. Write the limits 0 and t. We have used the same relation that we are using here. Okay. X and dx wala. So we'll get v minus u. First put upper limit in v. Now put lower limit in v. Lower limit is 0. So it's v minus 0. And here we have a. First put upper limit in t and now put lower limit in t. Okay. So no, it's not, it's 0, na? V minus 0 we have. Okay. So this is v is equal to 80. V is equal to 80. Now time is 1 second. Acceleration is 2 meter per second square. Acceleration is 2 meter per second square and time is 1 second. So velocity is 2 meter per second. V is equal to 2 meter per second. Okay, and close this in box. We've got the value of velocity. Now for displacement, we have to write. How do we relate displacement, time, and velocity in differential form? Array, V is equal to ds by dt. V is equal to ds by dt. So this implies ds is equal to v dt. Now integrate this. On integrating, we get ds. Put the limit 0 to s, and here a t dt, again put the limit 0 to t. Okay. नहीं, 80 बाहर नहीं आएगा बेटा, a बाहर आएगा. It's s minus 0 and here we have a. T square by 2 आ जाएगा. T square by 2, again put the limit 0 to t. So it's s is equal to half a t square. Now put the values. Acceleration is 2 and t is 1. Displacement is 1 meter. This is how